Okay, so our next discussion is about independence. The state tests also think that you understanding if two events are independent is very important, right? Independence means that one event does not affect the other event, right? If one event occurs, it does not affect the probability of the other event occurring. Does not affect probability. Okay, so that's the idea behind independence. So this is our prompt here. We have a jar contains 12 green marbles and 8 violet marbles. Ooh, violets. Huh? Okay, so a marble is chosen at random from the jar and replaced. So this is event 1. So event 1, a marble is chosen at random from the jar and replaced. Event 2, now another marble is chosen at random from the jar. Does the color of the first marble chosen affect the possible outcomes for the second marble chosen? So the most important word here in this problem is replaced. So when you take a marble out, there's a certain probability, right? So at the beginning, for green, the probability of green here would be, probability of green, if I could write a G. So the probability of green would be a 12 out of 20, because there's 20 total marbles. The probability of a violet would be 8 out of 20. When you pull the first marble out, that's the probabilities of getting each kind. When you replace it and pull out the second marble, these probabilities stay intact, which means the first marble has no effect on the second marble's probability. Therefore, they are independent. So since the first marble is replaced, the number of marbles is the same. For the first and second marbles. Therefore, the first marble does not affect the second marble. And that would make these independent events. Okay, all right. Now let's take a look at the same kind of prompt, but in a different way, right? One important word. A marble is chosen at random from the jar and not replaced. Another marble is chosen at random from the jar. Does the color of the first marble affect the possible outcomes for the second marble? So now, again, the first pool, you have a probability of green being a 12 out of 20. You have a probability of a violet being an 8 out of 20. But now on the second pool, your two probabilities are now going to be out of 19, which changes the probability of the second event, where therefore the first marble does affect the outcome for the second marble. And all because it says not replaced. So because the first marble is not replaced, there is one less marble in the jar for the second choice. Therefore, the first marble does affect the second marble. And that means that they are not independent. Right? If it does affect, then they're not independent. Okay, now we have an important rule for independent events that has to do with if they both happen at the same time. So right here is the probability of independent events. If A and B are independent events, then the probability of A and B equals the probability of A times the probability of B. Very important. They don't give you that formula on the state test, so be aware of that. Okay. So again, for instance, if you roll a die, a six-sided number cube, and you toss a coin, these are completely independent, right? They're completely separate objects. So if you want to find the probability of getting a 4 and a head, you would just take 1 out of 4 because there's a 1 out of 4 or 1 out of 6 because there's a 1 out of 6 chance because there's 1 4 out of the 6 sides, and then heads is 1 out of 2 because there's 2 sides and one of them's heads, and you would just multiply those probabilities together. And that's it. Okay. So again, that's probability for independent events. All right. So I got 2 more examples here. So example 4. Alex cannot decide which shirt to wear today, so she chooses one at random. The probability of rain today is 40% or 2/5. What is the probability that Alex chooses a yellow shirt and it does not rain? Okay, so yellow and not rain. So think about this, right? Does the shirt I wear and whether the Mother Nature is going to make it rain or not, are they related? No, right? Now again, if I see that it's raining, it might affect the shirt that I choose, but that's not the question here. The question is if I blindly choose a shirt color and it's not going to rain, how's that going to work? So these are independent events, right? So they are independent. So we just need to figure out what the probability of a yellow is and the probability that it not rain, because the probability that it will be yellow and not rain, so I will call that rain complement, right? Not rain is going to be the probability that it's yellow times the probability that it will not rain, rain complement. So up here, this 40% or 2/5, this is the probability that it will rain. Okay? So then the probability that it will not rain will be 1 minus that. So 1 minus 0.4, 1 minus 2/5, whatever you want to use, right? It doesn't matter. I'm going to use 0.4. Okay, 1 minus 0.4, because that's 40% as a decimal. In this closet here, the probability of a yellow is going to be 2 out of 4, right, which is 0.5. So to find the probability of getting a yellow and it not raining, I'm going to take 0.5 and multiply it by 1 minus 0.4. Right. So this is 0.5 times 0.6. I don't care how you do it, but you're going to get 0.3 or 30%. And there's how you find this probability. All right, next. Make it a little bit more complicated. Same prompt. Okay, what is the probability that Alex chooses a yellow shirt and it does not rain today, or that Alex chooses a green shirt and it rains today? Okay, so we have 1, 2, 3 probability questions to do. So this is what it's really saying. It's saying find the probability that he's going to wear a yellow shirt and it does not rain and not rain, or the probability that he chooses a green shirt and it rains. And we want to find the probability of that, right? That's what this problem is asking. So it's really 2 probability questions, and then just add the 2 together, okay? All right, because these are independent events. All right, so let's take a look here. So find the probability that he wears a yellow shirt and that it's not going to rain. Well, we did that, right? So this probability of a yellow and not rain is 0.3. We did that. Okay, so now let's do this over here. So the probability of getting a green shirt and it raining is going to be the probability of a green times the probability that it rains. Right? So there's a 1 out of 4 chance of getting a green. So the probability that it's green is 1 out of 4. That's 0.25. 0.25. I don't know what that is. So 0.25 times, and the probability that it rains is up here. So the probability that it rains is 0.4. So when I do 0.25 times 0.4, that's going to give me 0.1. So that's the probability that I choose a green shirt and it rains. So to find the probability of the or, right? Or you're just going to simply add 0.3 plus 0.1 because these events do not have any overlap, right? They're independent, they're mutually exclusive, so we just are going to add them, and that would be a probability of 0.4 or 40%. And there's our final answer here. Awesome, so very good. Again, statistics probability, you just kind of have to play with every problem. Every problem is kind of different. But again, we talked about mutually exclusive, non-mutually exclusive, and independent in this video. All right, good luck on the practice.